All right, in this video, we're looking at some special cases when multiplying polynomials. Let's perform this initial product here in example A, just like we would normally perform the products, and then we'll kind of observe something special about the result. So the way I perform the multiplication here is simply to multiply this first x value times the x value in the second parenthesis, and that'll give us, of course, x squared, and then I'll do x times the positive 3, which will give you plus 3x. Now I've multiplied this x here by everything in the second parenthesis, so I need to switch now to the negative 3. So I'll do negative 3 times the x, which gives you minus 3x. And then I'll do negative 3 times positive 3, which will end up giving us, of course, negative 9. Now, at this point, we combine like terms normally, and you can see that the two middle terms combine nicely. And in fact, they don't just combine, they cancel out, right? Because positive 3x and negative 3x will end up canceling out to 0. So that means we end up with a result of x squared minus 9. Now, what's special about this product is that result is considered something special because it's a famous product in algebra, and that product is referred to as the difference of two squares. The reason why we say it's the difference of two squares is because it literally is a difference, right? There's a subtraction symbol in the middle. And this first term is something squared, and this second term is something squared. So the binomial is referred to as a difference of two squares. The reason why this is helpful is that if you recognize that the pattern exists, you can simply square the first term in the binomial and then square the second term in the binomial, and that will give you the answer you're looking for. So you don't have to actually go through the full process of multiplication. So the key is, how do you recognize that this is one of those special products? Well, if you look back at our previous example, example A, you'll notice that they were exactly the same, the two binomials, except for the signs, right? So it was x minus 3 in the first binomial and x plus 3 in the second binomial. And that's the indication that we're dealing with a product that's going to produce a difference of two squares. So the binomials should look exactly the same, except for they have different signs in the middle. All right, so when you look at this second example, is this binomial exactly the same as this binomial except for the sign of the number 2? If that's true, then we're dealing with a situation where we'll end up with a product that's called the difference of squares. So if that's the case, we can simply take this first term and square it. So what's the square of 5x? Well, it would be 5x times 5x, or in other words, 25x squared. And then what's the square of this 2? It'll be 4, and then you put the negative sign between them. And there's your answer, the difference of two squares, or in other words, 25x squared minus 4. If you want to confirm that this is indeed the correct result, you can carry out the multiplication as we normally do. So we'd have what? 5x times 5x is 25x squared. Then we'd have 5x times a positive 2, which is going to give you plus 10x. And then you have minus 2 times 5x, which is negative 10x. And then lastly, negative 2 times positive 2 is negative 4. Putting these middle terms together that are alike, you see that they cancel out, and you end up with just 25x squared minus 4, the same result we had just a moment ago.